We will continue the presentation of CSEC Multiple Choice Practice Paper 3 with Part C, another 15 problems. Part C will consist of the problems from number 31 to 46. A rectangular field is 4x meters long and 2x meters wide. Its perimeter is 288 meters. The value of x is... The perimeter of a rectangle is given by... The perimeter is equal to 2 times the sum of the length and the width. And it is written 2, open bracket, length plus width, close bracket. 2 times the sum of the length and the width. Length, as we have it here, is 4x and the width is 2x. We have it right here, 4x meters long and 2x meters wide. We will substitute those in the formula. So we have 2 times the sum of 4x and 2x. 4x plus 2x is equal to 6x. The perimeter is equal to 2 times 6x. 2 times 6, 12. So 2 times 6x will give 12x. Remember that the perimeter is 288. We have it right here. The perimeter is 288. Therefore, 12x is 288, or we may say 288 is equal to 12x. X is being multiplied by 12. Now we have an equation and we need to solve for x. So x is being multiplied by 12. That's what 12x means. So to eliminate 12 from the right hand side, which is this side, we divide by 12 and keep the equation balanced also by dividing by 12 on the left hand side. So we will divide through the equation by 12. So 12 will be eliminated from this side when we divide by 12 here, and we'll have on the left hand side 288 to be divided by 12. If dividing 288 by 12 seems to be a tall order, make use of the fact that 12 times 12 is 144. And it is a little bit plainer now to see that 144 multiplied by 2 is 288. So 288 is twice 144. Therefore, 12 times 24 is equal to 288. By looking at 288, it may be a little bit difficult, or it might be that it may not occur to the candidate that 288 is related to 12 by a simple relationship. But understanding that 12 times 12 is 144 and 144 multiplied by 2 is 288, then it is easier to see that 288 is actually 24 times 12, or we may say 2 times 12 times 12. Turns out to be 24 times 12. Therefore, 288 divided by 12 is 24. So x is equal to 24. The correct answer is option A. Same problem. Let's take another look at it. There's your rectangle. Let us say that we were a little out of touch with the formula for perimeter. We could have used the fact that the perimeter is the measurement all around the rectangle. And if we are going to measure all around the rectangle, find the measurement all around the rectangle, then we will do that by adding all of the sides. Add all of the sides of the rectangle and that would have been enough. So let us do that. The perimeter, so we add first that side, which is the length, then the width, then another side, which is of course equal to the length, and finally the side that is also equal to the width. At this stage, we may substitute the value of L is equal to 4x and W is equal to 2x. So now that we have length plus width for the measurement all around the rectangle, we may then make the substitution as usual, or a similar one to the one that we have made before. So we have length is 4x, width is 2x, length is 4x, width is 2x. Therefore, we have a total of adding all of these, and what will the result be? 12x as before. So that is how we could have determined that the perimeter could have been 12x. And of course, after determining that the perimeter is actually 12x, we may equate that to 288 as before. Since we know the length to be 4x and the width to be 2x, we could have just used them instead of length and width, or we could have used them instead of L and W. So instead of writing L for the length and W for the width, where we see the length we put 4x, where we see the width we put 2x, like that. Then the perimeter would have been equal to the length first, which is 4x, then the width, which is 2x, another side which is of course equal to the length, 4x, and the final side also that is equal to the width, that also is 2x. So the perimeter is equal to 12x as before. That's all there is to it. The model of a boat is made on a scale of 1 to 10. If the capacity of the actual boat is 1000 meter cube, what is the capacity of the model? A general understanding of what will happen to the volumes of objects of the same shape when their dimensions are in the ratio 1 to 10 may be developed by experimenting with the cubes whose dimensions are in the ratio 1 to 10. So we will take two cubes and the dimensions are in the ratio 1 to 10. So that is our first cube with dimensions 10. No doubt the second one will be with dimensions 1. In both cases, volume is equal to length times width times height, but they are cubes. This turns out to be L multiplied by L multiplied by L, which is equal to L cubed. So, of course, that is because all of the sides of the cube are equal. So, for each volume, we will replace the L's with the numbers. So, in the first case, we will replace with 10. And in the second case, we will replace with 1. So we have the volume is equal to 1 cube, which is 1, and for this one is 10 cubed, which is 1000. So we will see directly that we have what? Dimensions 1 to 10, volume 1 to 1000. So that relationship is seen immediately. As a matter of fact, we should not have much difficulty after developing this understanding to determine the correct answer. It is obvious that when each dimension is 10 times, the volume will be 1000 times. The actual is 1000 meter cube. This tells us that the model was 1 meter cube, as we have in our illustration. So as we have it in this illustration, so it is in actuality, and as a matter of fact, as it pertains to the solution of this problem, because the model of the boat is made on a scale of 1 to 10, as we have them right here. and we have taken a look at the volume, which is of course capacity of this one and also of this one, and we realize that if they are in the ratio 1 to 10, the volumes will be in the ratio 1 to 1000. The correct answer is therefore option A. Now, let us use another scale, say 5 to 1. We will just take another look at another scale just to see if we have a general relationship developing with the scale of the actual dimensions and the scale that will relate the volumes. Right. We do not want to come up with a general rule just by looking at a single case, or in particular the case that is involved in the solution of this problem. So let us take a look at another case and see what we have. So we have them in the scale of 1 to 5, or 5 to 1 in this particular case. So the volume, as usual, we cube the length. And what do we know? 1 in this particular case and 125 in this case. In this case, the volumes are in the ratio 1 to 125. Observing that 1000 is 10 cubed and 125 is 5 cubed, we are sure that the volume of the cube, the both, and by extension any other model will be related to the actual by the cube of the scale factor. So as it pertains to volumes, then we are sure that the actual will be related to the model by the cube of the scale factor. Also, since the unit and the method of finding the area makes use of the square of the dimension, the areas of a model and an actual will be related by the square of the scale factor. So for volumes, we have the cube of the scale factor. For area, we have the square of the scale factor. So let us make light work of two examples on the next slide. Of course, the two examples will make use of volumes and areas, and also we take a look at the scale factors relating both. The dimensions of two plots of land are in the ratio 2 to 1. The area of the larger plot is 60 hectares. What is the area of the smaller plot? Since we are talking about areas, they will be in a ratio determined by the square of the scale. So where we have 2 to 1, the areas will be 2 squared to 1 squared, which is of course 4 to 1. Therefore, the larger plot will be 4 times the area of the smaller one. So the area of the large one is 4 times the area of the small one. The area of the small one, how do we find that? By dividing the area of the large one by 4. So 60 divided by 4 is equal to 15. So we have 15 hectares. The model of a cylindrical tank has a volume of 12 meters cubed. The actual tank will be constructed according to the ratio 1 to 3. The actual tank being larger, what is the volume of the actual tank? Since we are talking about volumes, they will be in a ratio determined by the cube of the scale factor. So whereas we have 1 to 3, we will have 1 cubed to 3 cubed, which turns out to be 1 to 27. the volume of the actual tank will be, of course, 12 times 27, which is 324. The answer is 324 meters cubed, or cubic meters. When dealing with areas and volumes, the shapes of the figures do not matter. The treatment will be the same. So I guess what could have thrown off some students is that the model and the actual were boats. So they may have been a little bit blindsided by the fact that we are talking about two boats. But it does not matter. As long as we are talking about volume, we talk about the cube of the scale factor. And as long as we are talking about areas, we talk about the square of the scale factors. 3 lights flash at intervals of 4, 6, and 10 seconds. They are started together. How soon after will they next flash together? Let us say that they will flash together x seconds after. X must be a number that is divisible by 4, divisible by 6, and divisible by 10. We do not need just any time after that the lights will flash together. We need the time that they will next flash together. So we have it here, next flash together. We therefore need the smallest number that 4, 6, and 10 will divide into without leaving a remainder. That number is the LCM of 4, 6, and 10. The options are in numerical order, with the smallest one first. If we can start at A, the first one that is divisible by all of the numbers will be the correct answer. So we need the LCM, so we need the smallest number. But it is good or convenient that the numbers in the option are already in numerical order, beginning with the first one. Therefore, we may begin at the first one, and the first number that is divisible by 4, 6, and 10 will be our answer. Option A is 40, and of course 40 is not correct because it is divisible by 4 and 10, but 40 is not divisible by 6. That means 6 cannot go into 40 without leaving a remainder. So we are sure that one is not correct. Option B. All of the numbers 4, 6, and 10 will be able to go into 60 without leaving a remainder. 60 is the smallest one among the options. It is correct. So after we have eliminated the 40, 60 is the smallest one that remains. And of course, since the numbers can all divide into 60 without leaving a remainder, we need not go to the others because we actually need the smallest one that all those numbers can divide into without leaving a remainder. So that is our correct answer, option B. We will now do some refreshers in finding the LCM. So let us do a refresher in finding the LCM. We are going to take a look at how we find the LCM. We will use repeated division, beginning at the smallest prime number that may go into any of the numbers until the entire set of numbers is exhausted. The table form will help us to do this effectively. So we are going to use the table form, and we will divide by the lowest, beginning of course at the lowest prime number until the list is exhausted. So there is our table, the first row, and we will begin our repeated division. But remember that we are talking about any number that the smallest prime number that we choose can go into. So if we say choose 2, which is of course the smallest one. If we choose 2, as long as 2 can go into any of these, it is not necessary for 2 to be able to divide into all of them. Just that it can go into 1. As long as it can go into 1, we will use it. So 2 is the smallest prime that will go into any of those numbers, of course, without leaving a remainder. So we use 2. Turns out that 2 can go into every single one of them. 10 divided by 2 is 5. 6 divided by 2 is 3. And 4 divided by 2 is 2. We may use 2 again because we find a single one that 2 can go into without leaving a remainder. So we will use 2 again. Only 2 is divisible by 2. The others will return in the next row. So if they are not divisible by 2 or any number that we choose, they return to the next row. But we say 2 into 2 is 1. So we divide the one that is divisible, but the one that is not, we will cause it to return to the next row, like so. The next smallest prime is 3. There we have it. Only 3 is divisible by 3. 5 will return in the next row. Right. And then finally, 5 is the only one that is left. So 5 can go into 5. Nothing else. Of course, it goes into 5 one time. The LCM is the product of all of those primes. So we have 2 times 2 times 3 times 5. We have it written here in a horizontal form. And if we multiply them, when we are multiplying numbers, we do it conveniently by saying 2 5s 10 and then 2 3 6, so that is equal to 60. We make use of the fact that when we multiply 2 by a number ending with a 5 or a 0, we end with a convenient number, like in this particular case 10. So 10 and then 2 times 3 6. So we have 60. So the LCM is 60. In the next method, we will write each of the numbers as a product of its prime factors. At the primary school level, we use tables. But at this level, if we need a table to do that, we may as well go back to primary school. So 4 is equal to 2 times 2. And then we take 6 and write it as 2 times 3. 10 as 2 times 5. Write down all of the prime numbers that we see represented there. So what do? We have 2, we must write it down. We have 3, we write it down. And 5, write that down also. So all of the prime numbers that we have represented here are to be taken note of. Then what do? Locate the largest number of 2's. That is, in the product of prime factors. So locate the largest number of 2's. 4 has the largest number of 2's. There are 2 of them. They will be included in the LCM. So the LCM will begin with 2 multiplied by 2. Then we take the 3. Locate the largest number of 3's. 6 has the largest number of 3's. There is only one 3, as a matter of fact. That will be a part of the LCM also. Then we identify the largest number of 5's. And that largest number of 5's belong to 10. There is only one 5. It will be a part of the LCM. And the LCM is like what we have calculated before. 2 multiplied by 2 multiplied by 3 multiplied by 5. And that is equal to 60. The largest number of prime factors is used in each case. in order to ensure that all numbers can divide into the proposed LCM. For example, if only 1 2 was used, 4 could not divide into the number that we would have received for the answer. So, say for argument's sake we just use only 1 2. We would have what? 2 times 3 times 5. And what is that equal to? That would have been equal to 30. And 30 is not divisible by 4. So in each case, we need to take the largest number of the represented prime in order to ensure that the numbers all can be divided into the proposed LCM. Finally, the lowest common multiple may be found by writing down a reasonable number of multiples of the numbers and identifying the smallest one that is present in all three lists. There we have all three lists. And in this list we have what? Multiples of 6. We have multiples of 4. We have multiples of 10. Find the smallest number that is present in all three lists. That is the smallest number that is present in all three lists. Each list represents the set of multiples of the numbers. We have located an item that is present in each list. It is therefore common to all. That common multiple turns out to be the lowest one that meets the requirement or meets the criterion. So we have lowest common multiple and the LCM is 60. So in each list we have multiples, multiples, multiples. Multiples of 6, of 4, of 10. Right. And we are locating one that is present in all of the list. So the one that is present in all of the list is the common one. And we are choosing the smallest one that is common. Therefore, we have the lowest common multiple. And that turns out to be 60. $32,747 written to 4 significant figures is, let us work that one out. We are focusing on the 4 significant figure. So we are highlighting this 4 because we are looking at the 4th significant figure. When writing a number correct to 4 significant figures, we first need to locate the 4th digit in order of significance by counting from the left. And at the left, we have the most significant digit. So we will begin at the left and we will count 4. So we have 1, 2, 3, 4. And we are right there. We have located the 4th digit in order of significance. Next, we check the digit that is next in order of significance, and that one will be located to the right. So that is the one that we are checking right here, this one. The digit is a 7, which is of course greater than 5. We therefore add 1 to 4. In the case that it is 5 or more, we will add 1 to the more significant digit. So, since it is greater than 5, we have no doubt that we need to add 1 to the more significant digit. Of course, more significant than 7. So we add 1 to 4, we get 5. The other digits to the left are not affected and return as they are. So the digits of greater significance will remain or will return just as they are. A placeholding 0 is included, maintaining the size of the number. Right, so if we did not have this placeholding 0, we would have been 1 place value short. which of course will turn out to be significant. The correct answer is option B. Without the place holding 0, the approximation would have been 3,275, which would have been a horrible approximation of 32,747. We would have had a horrible approximation of the number if it were not for that place holding 0. The number 0.0325 in standard form is, when writing a number in standard form, the number is increased or decreased by the number of decimal places required for it to have only one non-zero digit in front of or to the left of the decimal point. So we are going to adjust this number or increase it. Maybe that we need to decrease it by a particular power of 10 in order that we will have what? One non-zero digit. This is the first non-zero digit, and this one needs to be to the left of the decimal point. So we will do what it takes in order that we will have this 3 alone to the left of the decimal point. Count the number of decimal places that the number is increased or decreased by in order to have only one non-zero digit in front of or to the left of it. So we will begin. We haven't moved as yet, so 0. First movement is 1, second movement is 2, and we are right there. 2 places of decimal. And notice that we had 0.0325 before, now we have 3.25. Therefore, this represents an increase of the original. So if it were increased, what do we need to do? We need to make an adjustment that will bring it back down to its original value. So the number is increased by 2 decimal places. This means that we have multiplied by 10 to the power of 2. We need to recover the original value of the number by dividing by 10 to the power of 2. Its equivalent is a multiplication by 10 to the power of negative 2. So we are dividing by 10 to the power of 2, and the effect is multiplication by 10 to the power of negative 2. The leading zeros are unnecessary, so we do not have to include the leading zeros. So we have 3.25 times 10 to the power of negative 2. We may consider a number that initially has no non-zero digit to the left or in front of the decimal point as a small number. As a rule, we may say that numbers that are initially small should be accompanied by negative powers of 10 in the end. The difference between the number of decimal places in the initial statement and the final answer will tell us the size of the power. So we have what? A number that is small because it has no non-zero digit to the left of the decimal point. Therefore, the answer is to be accompanied by a negative power of 10. So what is that negative power of 10? The difference in the number of decimal places in the original statement and the final one is 2 places of decimal. So the power is required to be 2. But, as we said before, because it is a small number with no non-zero digit to the left of the decimal place, the accompanying power of 10 is required to be negative. So 10 to the power of negative 2. In the rectangle A, B, C, D, E is the midpoint of CD. AB is 16 centimeters and BC is 10 centimeters. the area in centimeters squared of the shaded region is, no doubt, E is the midpoint of DC. Not that it matters, because it does not matter. And we have AB is 16 centimeters. This one is 10 centimeters. I guess that the difficulty that candidates may express in solving this problem will be to find the area of the rectangle, then subtract the area of the two right-angled triangles in the end. So we may have a little bit of difficulty. Not that it is going to be harsh or way out. As a matter of fact, if we take that approach, I think that we could still finish the problem within examination time. But the difficulty that we imagine that the candidates may have is that they will see this situation and think that they need to find the entire area of the rectangle, then take away the areas of these two right-angled triangles in the end, like that. We will make light work of the problem by going straight ahead and finding the area of the shaded region. And of course that happens to be a triangle, like what we have right there. So the shaded region is represented by a triangle. We may consider it to be upside down, but that does not prevent it from having a base and a height. Its area will be found by making use of the same formula. Area is equal to half base times height. We may use any side of the triangle as the base, as long as the distance that we consider to be the height is perpendicular to it and goes from the base to the vertex that is not a part of the base. So in this particular case, the base is equal to 16 centimeters and the height is equal to 10 centimeters. As long as we have a triangle, we can use any side that we want to choose as the base. However, the distance that we choose to be the height must go from the base to the vertex that is not a part of the base, and it must be perpendicular to the base. In this particular case, we are choosing the base as AB. Therefore, we have the vertex A and the vertex B. So what we choose to be the height must go from the base to the other vertex and is required to be perpendicular to the base. Take a look at this again. Take a look at this again. Right. Notice that what we are using as the height is actually the width of the rectangle, which we know to be 10 centimeters. And we are considering that it is upside down and this is our base. So substituting those values for the base and the height, we have area is equal to a half of the product of 16 and 10. So A is equal to half of 16 is 8 and the 10 remains. So we have 80 centimeters squared, and that is represented by option C. A plot of land is 900 meters long and 850 meters wide. The area in hectares is... This is a knowledge problem. It requires us to know two things. The first one, do we know how to find the area of a rectangle? Well, it has to be a rectangle with only length and width given. So we are sure that it has to be a rectangle. And of course we are using the context of the dimensions and their names that were given to us. So area is equal to length times width. Substitute the values of the length and the width, so we are going to put those values in. 900 and 850. When we multiply those, we get all of 765,000 meters squared. The second one that we need to know, do we know how many square meters make a hectare? 10,000 meters squared is equal to 1 hectare. For the answer in hectares, we will divide the previous answer by 10,000. So what we have there, we divide by 10,000. In dividing by 10,000, we reduce the dividend by 4 places of decimal, in keeping with the 4 trailing zeros of 10,000. So we have, usually when we are talking about straight powers of 10, multiplying and dividing, we generally make use of simple rules. So we have, this is of course no doubt another power of 10, to the extent that we have 4 zeros here, 10 to the power of 4. So we need to reduce this by 4 places of decimal. And the answer is 76.5000. And we do not have it there. But we may remove the trailing zeros and we end up with 76.5 hectares. The correct answer is option B. We have two base 2 numbers of which we are required to find the product, and the answer is required also to be written in base 2. And of course base 2 is binary. Base 10 is denary, or we call that decimal. The problem is in binary, which is base 2, and the options are in binary, all of them. Let us just work in binary without having to use the subscript 2 all the time. So we will not be using 2, 2, 2 all the time as a subscript, because we are working in binary throughout. Let us set up our regular multiplication format. So regular multiplication, that's all we need. Then what do? We first multiply the multiplicand by the least significant digit of the multiplier, as we do from primary school up. Multiply all of these, the multiplicand, by the least significant digit of the multiplier. The result will be all ones. Good. Move to the next digit in the multiplier, which is the one of greater significance. So next, multiply the multiplicand by the digit of higher significance. This necessitates the inclusion of a place holding 0 in the position of lower significance. So apart from that, the result will include all ones as before. There we have it, all ones, but we need to have this 0 in the position of lower significance. Let us prepare to add the two sets of numbers. We will add the two sets of numbers as usual. Let us add, beginning as usual with the digits in the least significant position, those two. 1 plus 0 is equal to 1. No harm there. Move on. 1 plus 1 is equal to 2. I dare say. Just as in base 10, which is decimal, we do not have a symbol for 10. We write a 0 down and carry 1 to the more significant position. Base 2 is analogous. We do not have a symbol for 2. We write down 0 and carry 1 to the more significant position. Like so. Now we have 1 plus 1 plus 1, which is equal to 3. In base 10, which is decimal, for 11, we write down 1 and carry 1 to the more significant position. Similarly, in base 2, for 3, we write down 1 and carry 1 to the more significant position. Because 11 is 10 plus 1. For the 10, we will carry 1. For the 1 that remains, we keep it in the position of significance that we are adding in. For 2, we know that 3 is actually 2 plus 1. In binary, we say 3 is 2 plus 1. For the 2, we carry 1 to the position of greater significance, and the 1 that remains will occupy the present position. One plus 1 is equal to 2. Remember that in base 2, which is binary, there is no symbol for 2. When counting and we get 2, we write down 0 and carry 1 to the more significant position. So we will write down 0 and carry 1 to the more significant position. The correct answer is option B. In binary, it is just okay to think in terms of a number of 2's. If we have 45 in base 10, we say that we have 4 10s and 5 1s. In this event, we write down 5 and carry 4. For this reason, we do the similar thing for base 2, saying that 3 contains 1 2, carrying 1 to the more significant position. The remainder of 1 will occupy the present place value. In the figure, which point lies on the line LM? This is your typical linear programming straight line. The difficulty in this one is significantly reduced by the fact that the x and y intercepts are equal. Experience will tell us that the sum of the ordinates will give 5. X plus y is equal to 5. Let us see if anything else can tell us that x plus y is equal to 5. Okay, let us take a quick look at the equation of a straight line, which we know to be y is equal to mx plus c. Let us first find the gradient of the line, which is m, by dividing the change in y by the change in x. So we will go straight ahead to determine the equation of a straight line, and in particular this particular straight line. The fact is, because this is a typical linear programming problem, we need not go through all of this. But maybe someone in the examination could not quite recognize that because it crosses at 5 here and 5 there, that the equation of the line should be x plus y is equal to 5. We are therefore taking the necessary step to determine the equation of the straight line. So we have a situation where we need to find the gradient first. We do not have the gradient, so we need to determine the gradient first. That is what we have for the change in y, which is what will be in the numerator. The vertical shift is by 5 units, as we can see. 1, 2, 3, 4, 5 units, as we can see. What about the horizontal? The horizontal shift is by 5 units also. Good. Do not forget that a line that slopes in the direction of the uplifted left hand has a negative gradient. And that is George Overson showing us the uplifted left hand like that. So we are sure that the gradient is negative. 5 divided by 5 is equal to 1. Do not forget the negative sign. The gradient is negative 1. So the gradient, we are sure, is negative 1. And what do we know? Where it crosses the y-axis, that is the y-intercept. C is the y-intercept. C is the y-intercept, the value at which the line crosses the y-axis. The value of C is 5. So it crosses the y-axis at 5. The value of C is 5. Take the equation of the straight line. That is what we are going to write down now. The equation of the straight line. We know the value of the gradient, which is m, and the value of the constant c, which is the y-intercept. Substitute the values. M is equal to negative 1 and c is equal to 5. Right, so we have y is equal to negative 1x plus 5. But we know when a coefficient is 1, we do not have to write that 1 down. As a matter of fact, it is negative 1 in this particular case. So we need to write y is equal to negative x plus 5, and that will suffice. Without this one right here, it means the same thing. As a matter of fact, the negative 1, not the negative, but the 1 here is a matter of redundancy. Transpose x to the left hand side where it will become a positive x. So we transpose that negative x here, positive x on the other side. We have y plus x is equal to 5, and that is the equation. The equation of any line is a general rule that describes any point on the line. And in this particular case, it is saying that the sum of the x and y ordinates of any point on this particular line must be equal to 5. So, equation is a general rule that describes the points that are on the line. And the rule in this case is when we add the y value to the x value, the result is 5, every single point on that line. Among the options, identify the point whose ordinates add to give 5. So, x plus y or y plus x is equal to 5. What we need to do is add the ordinates and see which one gives 5. That one will be on the straight line that we have right there. 6 plus 0 is 6. No. 5 plus 5 is equal to 10. Not at all. 7 plus negative 1 is equal to 6. No, sir. Then we have 7 plus negative 2, which turns out to be the same as 7 minus 2. That is equal to 5. And that point is on our straight line. The correct answer is option D. The examiner expects us to be able to look at the line on the graph and tell that for any point on it, the sum of the ordinates must be 5, and arrive at the answer in a few seconds. So what is expected of us is for us to understand that if we have a line that crosses the y-axis at, say, 4, and the x-axis at 4, that the equation of that line will be x plus y is equal to 4. Therefore, any point on that line, if we add the x and y ordinates, we will get 4. And that same thing applies to this line. Any point that is on this line, if we add the ordinates, we should get 5. and we should be able to just look at the line and be able to tell that, if we are very skillful in the equation of a straight line and our mathematics in general. The point A, B is the image of the point 3, 5 after a reflection in the line y is equal to -1. The point A, B is, so we need to reflect that point, which is this one, in the line y is equal to -1. Before using a graphical representation, let us take a mental shot at the problem. We will not be using the grid as yet. We will see if we can do it in our minds. But of course, to do it in our minds, we have to have a good idea of what the system looks like, and of course, what the line y is equal to 1 looks like. The line y is equal to 1 is parallel to the x-axis, and the x-axis is a horizontal line. So the line y is equal to 1 will be parallel to the x-axis and will cross the y-axis at 1. So we expect that it will cross the y-axis at 1, and it is parallel to the x-axis. As a matter of fact, the equation of the x-axis is y is equal to 0. So y is equal to 1 will be a line parallel to y is equal to 0, the x-axis, and will be just 1 unit above that line, or 1 unit above the x-axis. When the point is reflected in that line, y is equal to 1, there will only be a vertical shift. When we are reflecting in a horizontal line, the point will be located, or the image will be located vertically below the original point. That will cause the x-ordinate of the original point and the image to be the same. So we have 3 for the original x-ordinate. The x-ordinate will be the same. The line is at y is equal to 1, and the y-ordinate of the point is 5. So the y-ordinate of the point is 5, and the line is y is equal to 1. The point is 4 units above the line. So 4 above the line. How did we get 4? 5 is where the point is located. 1 is where the line is located. 5 minus 1 is equal to 4. The point is 4 units above the line. When it is reflected, it will be 4 units below the line. So the point is 4 units above the line. When it is reflected, it will be 4 units below the line. And the line is at 1. So 1 minus 4 is equal to -3. The y-ordinate will be at -3. So we did not really need to use the grid if we have a very good mental image of the rectangular coordinate system. The correct answer is option D, 3, -3. Let us make use of the grid and see how our mental answer will match up with the graphical one. Or will it? Let us first introduce the point to be transformed and the mirror line y is equal to 1. Go straight ahead. So this is our mirror line and this is the point. The point is to be reflected in the line y is equal to 1. The line joining a point to its image must be perpendicular to the mirror line, and the point and its image must be equal distance from the mirror line. And let us say that again in another way. When we are reflecting this in the mirror line, wherever the image is located, it is required to be in such a location that when we draw a line from the point to the image, that line is perpendicular to the mirror line. Not difficult in this case because the mirror line is a horizontal line. So the line joining this point to its image will be a vertical one. it is present in the grid, so we have the vertical line right here along which the image will be located. Since the mirror line is horizontal, any line that is perpendicular to it must be vertical, as we said before. The point is 4 units above the mirror line. Its image will therefore be located 4 units below the mirror line. So the line that joins the points and its image is perpendicular to the mirror line, so this will be located, the image, vertically below. Also, the distance that we have from this point to the mirror line is the same distance from the mirror line to the image. So we have, from here, we have 1, 2, 3, 4 units. From here, we need to have 1, 2, 3, 4 units. Will be located right here. Good. And the coordinates of that point will be 3, -3. The correct answer is actually option D. So we have verified that it is option D. The line joining the point and its image will be vertical. There will therefore be no change in the x ordinate. And that is what we have all the time when we are reflecting in a horizontal line. No change in the x ordinate. If we are reflecting in a vertical line, there will be no change in the y ordinate. What is the place value of the 2 in the number? It is not 3,245 because that is not base 10. It is base 6. So it is 3245 base 6. The number is in base 6. Let us use an analogy with the base 10 or the decimal system to help us solve this problem. Usually when we are solving problem or any approach that we are taking to life, we most times use something that we are quite familiar with as a frame of reference. Something that we use in our everyday life or something that we use quite often. And we use that as our frame of reference. And our base 10 is what we use every single day. So let us write the number down with place values as if it were a base 10 number. Write it down like, say it is a base 10 number. And then if it were base 10, we have ones, tens, hundreds, thousands. What about the exponential forms? That's what we are going to be considering in a while. We have 10 to the power of 3, 1,000. 10 squared, 100. 10 to the power of 1 is equal to 10. And any number raised to the power of 0 is equal to 1. And this applies to 10 also. So any number raised to the power of 0 is 1. 10 to the power of 0 is 1. So replace the regular place values with their exponential form. 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, finally 10 to the power of 3. Do the same for base 6. In base 10, 10 to the power. In base 6, 6 to the power. The only difference is that the basis of the exponential form will be base 6. Alright. So 2. The place value of the 2 is 6 squared. Because this is the 2 and it's in the position that is related to 6 to the power of 2 or 6 squared. So the place value of the 2 is 6 squared. 6 squared is equal to 36. The correct answer is option B. 6 squared, 6 multiplied by 6 is equal to 36. So B is our correct answer. It is worthy of note that the problem did not require the value of the 2. it required the place value of the 2. It did not require the value of the 2, it required the place value of the 2. The value of any digit in a number is dependent on two things. A, the value of the digit itself, that is called the face value, and B, the position of the digit relative to the other digits in the number, and that is called the place value. So the value of a digit is dependent on two things, the place value and the face value. Value of number is equal to face value multiplied by place value. The face value is the value of the digit itself, and the place value is the value of the digit because of its position relative to the other digits that are in the number. In this particular case, only the place value is required. The most likely mistake to be made by candidates who understand all of the principles on which the problem is based is to neglect the word place and find the value. So, if they neglected the word place and find the value, they would have been multiplying the place value by the face value, and they would have received 72. This is consistent with option C, but is not correct. So they would have received 72, which is option C, but 72 is not correct. If theta is an obtuse angle and sine theta is 5/13, cos theta is equal to, and we need to find cos theta. In considering obtuse angles, it is appropriate to use the system of quadrants, in which angles are measured against the positive x-axis. An obtuse angle is between 90 degrees and 180 degrees. We need to find the cosine of an obtuse angle when the sine of that particular obtuse angle is given. We will need to make use of the system of quadrants. It is also important to note that the angles are measured in an anticlockwise direction. Let us show an obtuse angle. So we are going in an anticlockwise direction measured against the what? Positive x-axis. So we begin at the positive x-axis and we go in an anticlockwise direction. We are talking about quadrant this time, not bearings. It is also important to note that the trig ratio in question is with respect to the acute angle that the line makes with the horizontal x-axis. Let us mark the angle with an X and complete the relevant triangle. So there we have the relevant triangle and we are marking the angle with an X. Now we are going from here to the obtuse angle, which is of course between 90 degrees and 180 degrees. So we are locating that angle somewhere in here. Generally, we consider this line to be a true reflection of what an obtuse angle should be. No problem with that. Now that we have located the obtuse angle by using this line, when we are referring to the trig ratios, we need to do that by considering the acute angle between the line in question and the x-axis. Therefore, any angle that we are talking about, as soon as we locate the position of that angle by using a line like this one, when we are referring to the trig ratio, we have to consider the relevant acute angle that this line makes with the horizontal axis. Let us identify the sides of the right angled triangle relative to the angle x. The longest side is called the hypotenuse. It is opposite to the right angle. So there is our hypotenuse opposite to the right angle. The side that is on the other side of, facing, or opposite to the specified angle is called the opposite, which is, this is the specified angle. So that is our opposite. The side that is beside, alongside, or adjacent to the angle is called the adjacent. And there we have it. As we said before, this is the line that we are considering, this one. It is a line that is marking the obtuse angle, because the obtuse angle needs to go from 0, which is the positive x-axis, all the way to wherever the obtuse angle is located. But when we are talking about the trig ratio of that obtuse angle, we have to consider the acute angle that this line makes with the horizontal axis. So sine theta is opposite over hypotenuse. Right. Opposite over hypotenuse, 5 over 13. That means the opposite is 5 and the hypotenuse is 13. From what we see, opposite is equal to 5 and the hypotenuse is equal to 13. Do we put those in? Yes, we do. The opposite is 5 and the hypotenuse is 13. So cos theta is equal to adjacent over hypotenuse. In order to find cos theta, we need to find the adjacent side, because cosine is equal to adjacent over hypotenuse, and we do not have the adjacent. We are familiar with the right angle triangles and know that the one that we have is a 5, 12, 13. So students who know their triangles and are familiar with the basic right angle triangles, they know that triangle that we have right there is a 5, 12, 13. So they are sure that the missing side is actually 12. However, let us use Pythagoras' theorem, in which we are finding one of the missing short sides of a right angle triangle in order to prove our point. So we will use Pythagoras' theorem to prove our point, although we already know that it is 12. So remember, to find the missing short side, we say hypotenuse squared minus the other short side squared. So 13 squared minus 5 squared. 13 squared is 169. 5 squared is 25. Then 169 minus 25 is equal to 144. And the square root of 144 is equal to 12. Cos theta is equal to adjacent over hypotenuse. So what is adjacent? What is hypotenuse? Of course, we are putting the hypotenuse first. So adjacent over hypotenuse, 13 for the hypotenuse, 12 for the adjacent. So we have 12 over 13. What we have just found is the value of the cosine of the angle. The sign that will accompany it is dependent on the quadrant that the angle is present in. So let us take a look at a chart. Look at the following chart. So we know that the value is 12 over 13. We need to know what sign it will have, whether positive or negative. So there is our chart. Our chart is saying that this is the first quadrant. All trig ratios are positive. This is saying that this one is the second quadrant. Sine alone is positive. And the third quadrant, tangent alone is positive. Tangent alone. And here, the fourth quadrant, cosine alone is positive. Cosine alone is positive. We are in the second quadrant where sine alone is positive. Therefore, any other trig ratio will be negative. The angle is in the second quadrant where sine alone is positive. Cosine is therefore negative. So cos theta is negative 12 over 13. The correct answer is option A, negative 12 over 13. Of course, the negative sign may be written in the numerator or in line with the fraction bar. It may be written also in the denominator, but mathematicians do not like to have negative denominators in answers. So we do not write that typically. When we have a negative denominator, we generally write negative in the numerator or negative in line with the fraction bar. There's your little chart again. For the most part, teachers expect us to memorize the quadrants and the trig ratios that are positive in each of them. No doubt, they have systems and mnemonics that will help us to be able to do so. The quadrant in which all are positive is called A. The quadrant in which sine is positive is labeled S. The quadrant in which tangent is positive is labeled T. The quadrant in which cosine is positive is labeled C. Then they begin in the fourth quadrant and make a nice little word that you can memorize. Cast, C-A-S-T, C-A-S-T, C-A-S-T. That is how they do it. And they remember that what? Cosine alone is positive, all positive, sine is positive, sine alone, tangent is positive, tangent alone. What I prefer to do is show you why the trig ratios are positive or negative in a given quadrant, in order that you do not just memorize information without reason. So what I'll do is show you how we know that sine is positive here and cosine is positive there, tangent is negative there, and so on. Your quadrant is really your regular rectangular coordinate system with the positive and negative x and y directions. Right? It is your regular coordinate system actually, with your positive and negative x and y directions as we have them right there, and as you should be familiar with. Consider an angle, say 150 degrees. It is obtuse and will be in the second quadrant, right there. Remember that when considering trig ratios, the angle that the line makes with the x-axis is considered. So although we are talking about this 150 degrees angle, which is obtuse, when we are going to be going into the finer details with the trig ratios, we consider the acute angle that this line makes with the horizontal axis. Right? And we complete the triangle like that. Cos theta is adjacent over hypotenuse. Is it really? Yes, it is. In the system of quadrants, the horizontal line will always be the adjacent and the vertical line will always be the opposite. This line is always the opposite, the vertical line, and the horizontal line is always the adjacent. That is because when we are talking about the particulars of the trig ratios, we usually use the acute angle that the line makes with the horizontal axis. And that is why all the time the vertical line will always be the opposite and the horizontal line will always be the adjacent. The adjacent is in the direction of the negative x-axis. So this is your adjacent. See? Adjacent over hypotenuse. The adjacent is in the direction of the negative x-axis. This is the negative part of the x-axis. So it will be negative. So the adjacent is negative. Right. The hypotenuse is always positive, which is this one. Always positive. So positive. So what do we know? Negative divided by positive is equal to negative. And that is why cosine is always negative in the second quadrant. And we may say that the cosine of an obtuse angle is negative. Well, that seems a little bit quick and one off. So if we move to the next slide, you may want to revise the information that we have on this slide. But we have others on the other slide that we may discuss in order to give a more general appreciation of the principles involved. So we are considering the same angle now. What do we know? Sine is opposite over hypotenuse. Opposite over hypotenuse. The opposite is in the direction of the positive y-axis. It is therefore positive. So this is the opposite. And notice it goes up, right? Yeah, it goes right up. And up is in the direction of the positive y-axis. Right. The opposite then is therefore positive because it is in the direction of the positive y-axis. The hypotenuse is always positive. There is your positive sign. Positive divided by positive is equal to positive. Sine of an obtuse angle is always positive. That is why. Let us take a look at tangent. Opposite over adjacent. The opposite is in the direction of the positive y-axis. Positive going up. As long as it is going up, we know that it is in the direction of the positive y-axis. The opposite is positive. What about the adjacent? The adjacent is in the direction of the negative x-axis. It is therefore negative. So going in this way we are going. And we are going in the position or the direction of the negative x-axis. So the adjacent is negative. Positive divided by negative is equal to negative. The tangent of an obtuse angle is always negative. Good. Considering any angle that is in the third quadrant. So we throw in an angle that is in the third quadrant. Right here. So this is the line that we are talking about, and we complete it with this one. So the triangle that we are talking about is this one. So what do we know? We are talking about what? Cosine. Adjacent over hypotenuse. The adjacent is in the direction of the negative x-axis. It is therefore negative. What about the adjacent? The horizontal one is always the adjacent, right? Right, is in the direction of the negative x-axis. It is negative. Right. Good. And the hypotenuse is always positive. Right. So negative divided by positive is equal to negative. The cosine of an angle in the third quadrant is always negative. Tan theta is equal to opposite over adjacent. Tan is opposite over adjacent. Where is opposite? Opposite and adjacent. Tan theta is opposite over adjacent. The opposite is in the direction of the negative y-axis. Opposite, this one. Notice that we are down here now. In the direction of the negative y-axis. Down here. So the opposite is negative. In the direction of the negative y-axis. So it is negative. What about the adjacent? The adjacent is in the direction of the negative x-axis. It is therefore negative. Notice that the adjacent is still here. Right? The adjacent is still here. Because the adjacent is here, it is in the direction of the negative x-axis. So it is also negative. Remember that the angle is taken relative to the horizontal axis all the time. And we are talking about this acute angle that the line concerned makes with the horizontal axis, which is this one. Right. Now, negative divided by negative is positive. The tangent of an angle in the third quadrant is always positive. The sign of all trig ratios with respect to quadrants may be found by taking similar approaches. The exterior angles and the interior angles of a polygon are equal. How many sides does the polygon have? The interior angle I and exterior angle E of a polygon are always on a straight line. So there we have our polygons with the exterior angle shown here, interior, exterior, interior, exterior, interior, exterior, interior. As we observe at sight, in the polygons that we have, the interior and exterior angles are not equal. However, sight will not suffice, especially that we cannot conclude that the polygons are drawn to scale. So if we look, we will realize, or we may come to the conclusion, that the interior and exterior angles are not equal. But sight will not suffice because we cannot conclude that the diagrams are drawn to scale. If two angles on a straight line are equal, and why do we say two angles on a straight line? Because the interior angle and the exterior angle of a polygon are on a straight line. So if two angles on a straight line are equal, each must be 90 degrees. 180 degrees must be shared equally between them because angle on a straight line is 180 degrees. We have two of them. They are equal. One must be 90, the other must be 90. So we are sure that the polygon of which we are referring to, the interior angle is 90 degrees. So we may use our general knowledge, of course, after concluding that the interior angle must be 90 degrees. We may use our general knowledge of mathematics and declare that polygons with interior angles equal to 90 degrees are quadrilateral. They are four-sided. That is the correct answer. We are sure that polygons with all interior angles equal to 90 degrees must be quadrilaterals. We have already concluded that if the interior and exterior angles of a polygon are equal, then they are both equal to 90 degrees because they are angles on a straight line, and we have two of them. They are equal. One must be 90 degrees, the other must be 90 degrees. 90 plus 90 equal 180, which is the sum of angles on a straight line. Let us use the formula for the sum of interior angles of a polygon to determine the number of sides that the polygon will have. So let's say that we did not know that if the interior angles are equal to 90 degrees, that the polygon is a quadrilateral. We could have used the fact that each angle is 90 degrees to determine the number of sides that the polygon must have. The total interior angles of a polygon is given by the formula 180 multiplied by n minus 2. And that will give us the total of the interior angles of the polygon. Now, to find the size of each angle, we divide by the number of them. So if we know what all of the angles will add up to give, to find the size of each one, all being equal, to find the size of each one, we will divide by the number of them, which is n. So we divide by n. And we know that each one is 90 degrees. 90 degrees is equal to 180 times n minus 2 all over n. We will solve this equation and we will take the approach of eliminating the denominator from the right hand side eliminating denominators, we usually say we are flattening the equation. So we will multiply by n on the left hand side. And let's see what happens. In the meantime, we will expand this bracket by saying 180n minus, of course, 180 times 2. So 180n minus 360. So 90n is equal to 180n minus 360. Transpose 90n to the right hand side and 360 to the left hand side. So this will be transposed like this, and this will be transposed like that. This is negative, positive there. This one is positive, negative there. Of course, 180 minus 90 is 90. So we have 90n on the right hand side. That is equal to 360. That is what we get. And we are multiplying by 90 here, dividing by 90 on the left hand side. We get 4 is equal to n is equal to 4, which is the same answer that we have right there. If f of x is equal to 2x minus 3 and g of x is equal to 3x plus 1, then f of g of negative 2 is equal to which one of these options is correct? F of g of negative 2 means that f is operating on g, while at the same time g is operating on negative 2. Since it is a function g that is operating on negative 2 directly, we may find g of negative 2 first, then allow f to operate on the result. In finding g of negative 2, take the function g. What is g equal to? G of x is equal to 3x plus 1. Substitute the value of negative 2 for x. So where we see x, we put negative 2. So g of negative 2 is equal to 3 times negative 2 plus 1. Now 3 times negative 2 is negative 6. And we have plus 1 carried from the previous step. Negative 6 plus 1 is equal to negative 5. The result is to be substituted in the function f because we have found g of negative 2 and f is operating on g of negative 2. G of negative 2 is negative 5, so f will now operate on negative 5. So f of x is equal to 2x minus 3, and substitute the value negative 5 for x. We have f of negative 5 is equal to 2 times negative 5 minus 3. 2 times negative 5 is negative 10, and we have the negative 3. Negative 10 minus 3 is negative 13. Whenever we are adding numbers that have the same signs, we add the values and the answer will take the same sign as the numbers that we have added. Negative 10 minus 3 is negative 13. The correct answer is option A. Good. We will take a look at another method by which a problem may be solved, but this one is preferable under examination conditions. When we are in an examination, we want to use this method to solve a problem that is like this one. We may take also another approach that will cause us to be home and dry nonetheless. We may take another approach in solving the problem in which the composite function f of g is found first, because as a matter of fact f of g is acting on negative 2, so we find f of g first. Then the value negative 2 will be substituted in the place of x in that composite function. we need to find f of g of negative 2, we may find the function, the composite function, f of g first. In finding f of g, take the function f, which is the one leading function, take f. Then what do? Substitute the function g into it. So in the function f, where we see x, we will replace that with g. So we have f of g is 2g minus 3. Further, we will replace the occurrence of g with the algebraic representation of g. So where we see g, we will put the algebraic representation of g, which is of course 3x plus 1. Right. G is replaced by 3x plus 1. We will expand the bracket and simplify. So we have 2 times 3x is 6x and 2 times 1 is 2. So 6x plus 2 minus 3. 2 minus 3 is negative 1, so 6x minus 1. That is the composite function f of g is 6x minus 1. Now that we find f of g, we need to find f of g of negative 2. We have f of g. We need to include that negative 2. We will next make use of the composite function f of g. F of g of x is equal to 6x minus 1. Substitute the value negative 2 for x. So where we see x, we put negative 2. We get 6 negative 2 minus 1. 6 times negative 2 is negative 12. And we have the negative 1 to consider. Negative 12 minus 1 is equal to negative 13. The correct answer is option A, as we have determined on the previous occasion. If f of x is equal to 4x minus 3, then f inverse is equal to what? I want to know. When finding the inverse of a function, we are attempting to write it in the reverse. While doing this, we have to consider that the function is operating on x. And the inverse should do the same. It should also operate on x. We may ask the question, how is the function operating on x, which is the wise thing to do? And we take a look at the function, and what do we notice? The first one is that x is being multiplied by 4. So that is 4x. X multiplied by 4. And what else? 3 is then subtracted from the result. So we notice that we have 4x, which is 4 multiplied by x. Then 3 is subtracted from the result. Reverse the process by doing the opposite of the operations that we have there. The order should also be reversed. So what we have there is what? We are multiplying by 4, and then we are subtracting 3 from the result. That is what we have right there. Now we are going to reverse that process, and the order of the operation must also be reversed. So the reverse of this one will go second, and the reverse of this one will go first. So a lot of reversing right there. So we do the reverse operations, and we do them in the reverse order. So the order is reversed right there. We need to throw in the reverse of each one. So 3 is then subtracted from the result. That is what we are talking about, this one. We need to throw in the opposite of that one. First, add 3 to x, and that is x plus 3. Then we take the other one. X is being multiplied by 4. What's that? Then divide the result by 4. So that's the opposite of multiplication by 4. The correct answer is option B. According to the syllabus, candidates should be able to just write down the inverse of simple functions. The one in this question is in that category. My students are always trained in finding the inverse of functions like these, and also they are required to do that mentally. As a matter of fact, they are able to find the inverse of much more difficult functions without a single stroke of the pen. They can find the inverse of those functions and similar ones mentally, and for some of the functions that are more difficult, they are still able to find the inverse of those functions mentally. In another approach to finding the inverse of a function, transposition of formula may be used. We initiate the reverse of the process by writing x in the place of f and f in the place of x. So begin with the function f. There we have our function f. Where we see f of x, we put x. Where we see x, we put f of x. So we are reversing the process. So write x in the place of f of x and f of x in the place of x. Like that. When the process is completed after transposition, the result will be the inverse of the function. It is therefore more appropriate to write f inverse of x than to write f of x. So when the process is completed, we would not have found f of x. We would have found the inverse. So it is appropriate to replace f of x with f inverse of x. Good. Transpose negative 3, the sign will be changed to positive. So this negative 3 will be transposed. And we have x plus 3 is 4 times f inverse of x. Eliminate the 4 from the right hand side by dividing by 4. So x plus 3 over 4. And that is equal to f inverse of x. So f inverse of x is x plus 3 over 4. Write f inverse on the left hand side, which is what we have just done. Making f inverse of x the subject of the formula. It is always appropriate when we have a subject to cause it to end up on the left hand side. So f inverse of x is x plus 3 over 4, as we have determined before. In order that the expression might be less cumbersome, teachers always encourage students to replace f of x with x and x with y. This just eliminates the use of f inverse of x throughout the entire process and serves no other purpose. Teachers say replace f of x with x and x with y. So we have instead x is equal to 4y minus 3, and that is so that the expression is far less cumbersome. It serves no other purpose. After doing the transposition, the result will still be the inverse of the function.